Welcome back to our channel, that is Ajay Kumar Yadav, and we are going to talk about the equation of motion by calculus method. So last class we have been talking about the equation of motion by ordinary method, but in today's class we are going to talk about equation of motion by calculus method. So in this equation of motion, we have been talking about V is equals to U plus AT, S is equals to UT plus half AT square, and V square minus U square is equals to 2AS. So let's begin our first equation of motion, that is, let's begin our first equation of motion, which is considered as the part for defining the calculus method, that is first equation. So we'll write it as acceleration is equals to, so acceleration is defined as, in that sense we have to write the equation. Acceleration is defined as rate of change of velocity. Rate of change of velocity is called as the acceleration. So this is the definition part of your acceleration. So we can also write it as A is equals to dv divided by dt. Then we have to go for a cross multiplication. A into dt is equals to dv. Then here we need to define the equation between dv as a one set of the variable, time duration change in time is the another set of the variable. So we can say here as applying the integration formula on both the ends, a of dt is equals to integral function dv. So in this part we are integrating the values on both the side, and the integration of both the sides will begin from, for v section it is 0 to v, and for a dt it is from the, even we can write v section as u to v we have to write, and a dt as 0 to t. So we can also write it as, we'll remove the a outside, under the integral function dt from 0 to t is equals to, under the integral function u to v dv. Now after integration we have to apply the equation as a into t. Limits have been extended from 0 to t, and here we'll write the limit extended from integral of dv is v from u to v. So we can also write it as a of t minus 0, which is also called as the v minus u. So at last we can say that a of t is equals to v minus u, or we can also write it as v is equals to u plus at for the first equation of motion under the calculus method. Now we will extend our calculation part to the second equation of motion, that is in terms of velocity. So let us talk about the velocity as well. Velocity is defined as, sir, how can we define the velocity there? Velocity is defined as rate of change of displacement. Rate of change of displacement is considered as velocity. So rate of change of displacement is considered as velocity. We'll write it as v is equals to ds divided by dt. We can also call it as v of dt is equals to ds. In the sense we can write v as u plus at, and integral function of dt is equals to d to s. Now as we know very well, we have to apply the integration. So we have to apply the integration to the both the ends. So after applying the integration to the both the ends, so for dt we have to apply the limits from 0 to t, and for the ds we have to apply the limits from, here we have to apply the limits from 0 to t, here we have to apply from 0 to s. So let us see the next part of it. After this what we have to do, we have to remove the brackets. So u of dt plus at into dt is equals to integral function 0 to s into ds. I hope you will understand more better by applying the integrations on the both the sides. So for u dt, what is the integration formula for u dt? That is limit extended from 0 to t. And then at dt, we can apply the limit extended from 0 to t and followed by 0 to s. So we have to apply the integration here. So we'll write the equation again, rewrite the equation. U of dt plus a of t dt is equals to integral function 0 to s ds. We will apply the integration on both the ends. So this is from 0 to t, and the next one would be from 0 to t as well. This is also 0 to t, that is also 0 to t. So we'll take the u outside. So integration of 0 to t dt. Now we will simplify. A of integration from 0 to t, that is t dt, which is equals to integration 0 to s ds. So we can also write the equation u as t under the limits from 0 to t plus times of a, that is t square by 2 under the limits from 0 to t is equals to s integration from 0 to s. So we can write upper limit minus lower limit now. So u of t minus 0, that is plus times of a t square by 2 minus 0 square by 2, and the last limit would be s minus 0. So removing all the 0 parts, we'll get the final derivation. So u of t plus a of t square by 2, which is equal to s. We can also rewrite the equation as s is equals to ut plus half times of at square. That is the derivation part for the equation of motion. Next we have third equation of motion. As we know very well, sir, how can we define the third equation of motion? In the third equation of motion, we can define that v square minus u square is equals to 2as. So we will rewrite the definition between acceleration and velocity. As we know very well, how can we write the acceleration? Rate of change of velocity. Rate of change of velocity is called as the acceleration. So in this we will write it as a is equals to dv by dt. We can also write it as multiplying the ds and dividing by ds on both the sides. So ds by ds into dv by dt. We can also apply integration by parts method. As we know very well, we can write dv by ds or ds by dt. So since you know very well all these terms, you will be familiar with these terms, I hope so. So we can also write dv by ds and ds by dt. So we know very well dv by ds does not resembles any quantity, but ds by dt we can write it as in the form of an v. So as you know very well, what is v? Rate of change of displacement is called as the velocity. So in this velocity, what we have to do here? We have to apply the terms as integration. As we know very well, integration. In this integration part, we can say that if displacement velocity v is displacement distance traveled is 0, time is 0, then the velocity will be u. So we can say if my initial velocity is u, then distance traveled which is equals to the 0, and the time is equals to also equal to 0. Similarly, final velocity v is occurring there, then the distance traveled will be s. distance traveled will be s, and the time duration obviously we can say that it is t. So here we can write the equation as the cross multiplication, that is a is equals to dv by ds into v. So we can go for a cross multiplication. A ds is equals to v dv. We have to apply, as we know very well, we have to apply the integration formula there, integration form. After applying the integration, a will begins to come out, and this terms will be ds, which is equals to v will come out. Since v and dv both are similar functions, so we can integrate between them. And the limits extension. Now what will be the limit there? Limit will be extended from 0 to s, and it is from u to v. So here it is limit extended from 0 to s, and it is integration from u to v. U to v, that is v dv. So we can also write this equation in the other sense as integration form. I will rewrite this equation, that is nothing but a of ds is equals to v of dv under the integration from u to v, and under the integration from 0 to s. So removing the a outside, now we have to integrate the form. ds is equals to v square by 2 under the limits extended from u to v. So we can also integrate this value as a of s, upper limit as s, lower limit as 0. So we will write this equation as v square by 2 minus u square by 2 under the equation, and we can write it as a of s minus 0 is equals to v square minus u square by 2. We can also write it as 2as is equals to v square minus u square. So my third equation of motion will be derived as v square minus u square is equals to 2as. Now we'll extend up to the fourth equation of motion as well. As we know, we have discussed earlier regarding the fourth equation of motion. Sir, how can we define same formula we have to implement there? Fourth equation of motion. What would be the fourth equation of motion? V is equals to, as we know very well, velocity is defined as, velocity will be defined as, what is velocity will be defined as? Yes, obviously rate of change of displacement. So we can write it here as v is equals to ds divided by dt. I will write and make you understand. Rate of change of displacement, that is called as the velocity. So we can also write the derivation part as v is equals to ds by dt, since we have to cross multiply and remove the values. So v of dt is equals to ds. Yes, now we have to implement the integration. For v, we have to integrate it from the time duration extended from the u minus 1, that is time extended from the u minus 1 n minus 1 to the n, and we can also write the ds extended from sn minus 1 to the sn. Sir, why it is from n minus 1 to the n and sn minus 1 to the sn? Since we know that the for time duration, let us consider the time duration n minus 1 seconds. For time duration n minus 1 second, the distance traveled would be, how much must be the distance traveled for n minus 1 seconds? The distance traveled would be nothing but sn minus 1. And for the time duration n seconds, for time duration n seconds, the distance traveled would be sn. So this is this equation or this derivation makes more sensible to understand towards the n minus 1 seconds and the sn seconds. Next we are going to implement and derive this equation. Let us start that. Since we know that v of dt can be written as u plus at and dt is equals to integration from s of n minus 1 to the sn into ds under the integration from n minus 1 to n. So now we have to remove the brackets. U of dt plus a of t dt is equals to integration extended from sn minus 1 to sn into ds. Now we have to integrate still more values, that is from n minus 1 to n. So n minus 1 to n, and this here also we have to apply n minus 1 to n. So if I integrate u of dt, what will be the term I will get there? U of t. So we will get the term as a, that is nothing but t limit extended from n to n minus 1 plus times of a integration n minus 1 to n t dt is equals to integration from sn minus 1 to sn into ds. Next, we have to also apply the derivation part, that is nothing but a of t upper limit t o n minus n minus 1 under the bracket, so that you can understand very clearly. You can understand more clearly. N or minus n minus 1 plus times of, we have to apply t square a into t square by 2 under the limits from n to n minus 1. I hope you will be very clear regarding the upper limit and the lower limit. And for ds, we can write it as s times of sn to the sn minus 1. So let us apply the terms a times of n minus, remove the brackets, n minus n plus 1, hence bracket is removed here, this lower bracket is removed here. We can also write it as a of n square by 2 minus times of n minus 1 square by 2. I hope you will be very clear. Next, so we can take the 2 out and we can write it here sn minus 1, sn minus 1. So we can also write, just we have to simplify, a times of n minus n plus 1, n minus n means 0 only, that will conclude in the next part, plus times of a by 2 n square minus of n minus 1 the whole square is equals to sn minus 1. I hope you will be understanding very clearly. After this, we have to conclude the equation, that is, that equation we have to conclude it as nothing but, since n minus n is 0 only na, so 0 plus 1. We can write it as a also. Here we can write it as a by 2, that is n square minus 2n plus 1. This is n minus 1 means a minus b the whole square. You know what is a minus b the whole square? sn minus 1. Am I right? So we can also write it as a plus times of a by 2, that can also be written as, remove the bracket, multiply the minus inside, n square minus n square plus 2n, and plus will become minus 1. So now the lower bracket is removed now. So sn minus s of n minus 1. So we can also write the final equation as a times of a by 2 2n minus 1, n minus n square, that is 0 only na. So 2n minus 1, which is equals to sn minus 1. So the my final derivation will stand as a plus a by 2 2n minus 1. So this is what I can also write my equation, that is nothing but u. Since I have written here as u, so we have to follow here as u only. not the a. We have to follow here as u. So all the terms we have to represent in the form of an u only. It is a u. All the terms represented as u. So a u plus a by 2, I'll rewrite this equation, u plus a by 2, 2n minus 1, which is equals to sn minus 1. This is how my final equation will stands there. So we have seen the various types of the equation. First equation of motion by calculus method. We have seen the second equation of motion, the part by the calculus method. We have also seen the third equation of motion by the calculus method, and we have also seen the derivation part for the fourth equation of motion. And this is how we can define the four equations of motion by an calculus method. Since you can also give a try, you can also give a practice, so that we will have a clear discussion about the next topic in the upcoming classes. That's all about this channel. Keep subscribing, keep updating this channel. Thank you very much for the patience.